So in this case, for question 2, they say that a small disk, right, C is in this case, no, actually not that, actually wrote wrong long, so that's actually SC, right, not SK, right. So in this case, they say that in this case, a small disk C is thrown vertically upwards at a velocity, at a speed of 15 meters per second from the edge of the roof of a building of 30 meter. All right. After 0.5 seconds, a small ball B is shot vertically upwards from the foot of the building at a speed of 40 meters per second in order to hit disk C. They said that disk C took, in this case, 1.53 seconds, right, to reach its maximum height above the building. They said that they ignored the effects of air resistance. Now they said that determine the position of ball B above the ground at the moment when it hits disk C. So in this case, remember we said that in this case, when two objects pass each other or when they hit each other, in this case they'll simply have the same height above the building. So we must keep that in mind. So in this case, what would happen is that this object would actually go up, reach its maximum height somewhere there. Right, unfortunately, let me just see if I can do something about this thing that I have here. Actually, yeah, can actually do something there. Right, so in this case, this object will go up, right, it will reach a certain point there, right. They say that it reached that point after after, in this case, 1.53 seconds. So it reached that point there. In this case, what would happen is that this object will go down, continue to travel down. Now in this case, they say that in this case, object P in this case was actually projected upwards. So in this case, what would happen is that in this case, this object will meet at a certain point. All right, in this case, they will hit each other at a certain point. But remember, we said that in this case, when two objects in this case pass each other, they actually have the same height, in this case, above the building. Now one might ask that, how did you know in this case that in this case they would pass each other below that building? Now I do not know, but in this case your assumption must always be that in this case they pass each other, in this case, below the building. So in this case, if they did not pass each other, in this case, below the building, that would actually be determined in this case by the value of x when you actually find that that value there. You see what I mean? But in this case, what we must simply just do would be to just in this case assume that in this case they passed each other, in this case, below the building. So if they did not, your answer for, in this case, for x, in this case, for x there. So in this case, what I'm simply going to do would be to let the height, in this case, above the ground to be, in this case, to be x. So in this case, if in this case they met, in this case, below, above that building, so in this case, what will simply happen is that value of x would simply be greater than 30 meter. So in this case, what you simply do, you just do it the same way. Just assume that in this case they passed each other, in this case, below in this case, the building. So if they did not, you simply find the value of x to be greater than 0. Right. So in this case, what I'm simply going to do, and remember that we said that they said determine the position of the of ball B above the ground, in this case, at the moment when it hits disk C. Now, so in this case, we're simply going to do the same thing. So in this case, what I'm simply going to do, I said I'm going to let this to be x. So in this case, my focus, I'm simply going to put my focus, in this case, on object C, the one which was projected first. So in this case, I'm going to make that the time, how long it took, in this case, to reach, in this case, this point. So in this case, I'm simply going to let this point to be, in this case, point A. So this will simply be, in this case, point B. So it simply be, in this case, point C, where they passed each other. So it simply be A, B, C. So it simply be, in this case, point D. So in this case, what I'm simply going to do would be to let the time taken by object C to reach, in this case, point C, in this case, to be, in this case, to be t. So in this case, what I'm simply going to do would be to say that in this case, between point A and C. So the reason why I chose between point A and C is that in this case, what I'm simply going to do would be to let the time taken by these objects to reach that point by the disk C, the time taken by that object to reach point C, to be t. So in this case, that would simply mean that the time for the second object simply be whatever time taken by this object minus, in this case, the late time. So in this case, what I'm simply going to do would be, so this would be, in this case, for disk. So I'm actually making the same mistake there. That's actually disk C. My English is actually running away from me again. So in this case, I'm going to say that between those 2 points, A and C, so that simply means that in this case, my V initial, again, I'm going to choose upwards as positive and downwards as negative. It really doesn't matter. I can take upwards as negative and downwards as positive. It really won't make a difference. Right? But in this case, remember that if you are trying to find, if you are trying to calculate velocity, so in this case, you simply just need to interpret that your answer in terms of direction, and in this case, or magnitude and direction. So that simply means that V initial would be 15, positive 15. Why in this case? Because it was projected upwards. As in this case, from that point. So in this case, my V final is unknown. I don't know. Right, in this case, when they pass each other, that in this case at what velocity was disk C moving. But in this case, I know that delta t, I'm going to let the time taken by object C to reach that point C to be in this case t. Right, so in this case, that simply means that in this case x. Now remember that if I let this height above the ground to be x, so that simply means that that remaining there would simply be 30 minus, in this case, minus x, that the one that is left there. So that simply means that in this case, for object C, my displacement would simply be in this case negative, right? But so this case would be negative 30 minus x, right? So in this case, the reason why it is negative there simply because in this case this object was displaced in this case 30 minus x meter, but in this case below the building. So this is simply the direction, right? So in this case to simply become, so in this case my delta a, in this case a, the acceleration simply be negative 9.8. So in this case what I'm simply going to do there would be to, in this case, now remember that I'm trying to find in this case a position. So in this case, any equation that I choose must have in this case delta x, but in this case, any equation that I choose must not have in this case the final velocity, because in this case I do not know that at what velocity where these two objects are moving, right? So in this case there would be nothing common about them. So in this case what I'm simply going to choose would be that in this case that the formula which says that in this case delta x equals to, in this case vi multiplied by delta t plus, in this case, half multiplied by a multiplied by t squared. So in this case my delta t, my delta x simply be in this case negative 30 minus x. All right, so that's 30 minus x equals to, in this case, velocity initial, which is 15 multiplied by t, right, plus half multiplied by negative 9.8 multiplied by t, which will simply be in this case just t squared. That's t squared there. So in this case simply become now negative, so simply become in this case x minus 30 equals to, in this case 15 t, in this case minus 4.9 t squared. So in this case I'm going to let this to be my first equation. So in this case what I'm simply going to do would be to create in this case a second equation, but in this case using this as case object, the second object, but in this case choosing my points be from, in this case where it started to where, in this case, it passed that other object, which would be at point C. So I'm going to say that between point D and C, this in this case this would be in this case for ball B. So in this case what I'm simply going to do there would be say Vi simply is 40, because it was projected upwards. So my velocity initial, I do not know that. My delta t, in this case, remember that this was actually projected in this case 0.5 seconds later. So in this case, if it took object C to get to this point t seconds, so that simply means that it took this object there to get to that same point t minus, in this case minus the lead time. So in this case simply be equal to, in this case t minus 0.5 seconds. So in this case I would know that in this case my displacement would be that x there, so it simply be equals to x, and my a would simply be in this case negative 9.8. So in this case what I'm simply going to do would be to say delta x simply equals to vi multiplied by delta t plus, in this case, a half multiplied by a multiplied by t squared. So in this case this simply be x equals to vi, that's actually, I think that's 40, right, multiplied by, in this case, t minus, this is 0.5 plus a half multiplied by, in this case, negative 9.8 time, that's actually t minus, in this case, 0.5, but in this case you square that. So in this case what you're simply going to have there would be, in this case, x being equals to 40, t, you distribute that, minus, in this case, negative 20, minus 20. So in this case simply be in this case minus 4.9, multiply that in this case by t. So in this case, if I open those brackets, remember that this simply equals to, in this case, t minus 0.5, t minus 0.5. So in this case, I'm simply just gonna do a quick math there. So in this case simply become now t squared minus, in this case, t, in this case plus, in this case 0.25, right? So in this case I'm simply going to multiply that out. So in this case, if I multiply that out, what I'm simply going to have there would be, in this case, so this simply be x equals to, so this is 40, t minus 20, minus, in this case, 4.9 t squared, minus, in this case, so it's positive 4.9 t. All right, so in this case, what I have there would simply be, in this case, now this multiplied by that. So in this case, what I'm simply going to have is minus, I think that's minus 1.225. So in this case, what I'm simply going to do would be to collect like terms there. So in this case, simply be x equals to, so in this case, be, I'm going to put this first. So this is simply become now negative 4.9 t squared. In this case minus, and this is, I think that's minus there. So if I put this 40, in this case 40t, in this case plus, in this case 4.9t, so that's actually positive. This is 44.9, and a t, in this case, if I add this 2, that's actually going to give me, in this case, a negative 21.225. So in this case, simply become now my equation, in this case 2. So in this case, you notice that it's actually easy to isolate x. So in this case, what I'm simply going to do would be to do the same for that one. So this simply become now x being equals to, in this case, of negative 4.9 t squared. I'm just rearranging that, plus 15 t, right? But in this case, I'm going to take that 30 to the other side. So it's simply become now plus 30 there. So in this case, what I'm simply going to do would be to say, but x equals to x. So in this case, I would know that in this case, negative 4.9 t squared plus 44.9 t minus, in this is 21.225, right, equals to that other equation, which says negative 4.9 t squared. In this case, I think that's plus 15t, this case plus 30. So in this case, what you can actually note there is that this is gone with that one. So in this case, what I'm simply going to do would be to collect like terms there. So in this case, I'm going to have, in this case, 44, in this case minus, in this case 15, when I take it to that other side. So in this case, what I'm simply going to have there is simply, in this case, that's 44.9 minus 15. So this is actually going to get 29.90. And if I say, in this case, 30, right, plus 21.225. So in this case, what I'm going to have is 51.225. And I'm just, going a little bit faster there, so that in this case, we don't make this the longest video, even though I feel like it's already long. So in this case, my t would simply be now, in this case, if I divide that, so it's actually going to be 1 point, in this case, 7, 1, 3, so on and so forth. And remember that I can't round that off early. Why? Because in this case, what I'm simply trying to calculate there is, in this case, the position of ball B, which is x. In this case, above the ground, right? So in this case, so what I'm going to do would be, now, since that I found in this case t, so in this case I'm simply going to take this that first equation. So in this case, it looks a little bit simpler. So in this case, I know that x is equals to, in this case, negative 4.9 t squared plus, in this case, 15t plus 30. So in this case, simply be equals to negative 4.9. This is my t, that's 1.713 blah blah blah, right? In this case, that's squared plus 15 multiplied by, in this case, 1.713, and so on and so forth. Right, in this case, so in this case, plus 30. So if you put that into your calculator, I think the value that you're going to get there would simply be, in this case, 41 point, in this case, 32. So in this case, you note that, in this case, remember what I said, if they met each other, in this case, above that of the building. In this case, it will be actually be determined by the value in this case of x. So in this case, the logic still the same there. Just do the same thing. In this case, the answer will come out in this case itself. In this case, if in this case your calculations are correct. So in this case, what I'm simply going to do would also be to draw the graph, velocity versus time graph, also for these objects, right? So in this case, suppose in case if they ask it. So in this case, what I'm simply going to do. All right, so this, remember that of course this cannot be negative. So in this case, you're gonna have that like that. So in this case, I know that in this case so I'll have, so for object A, the first for object C, so I have that initial velocity to be 15. In this case, for the second one, so in this case, its velocity is actually that 40. But in this case, remember that in this case they say that in this case this object, now if you look at the time that you got, right, and what they said in the statement, they said that it took disk C to reach its maximum height 1.53 seconds. So in this case, this tells me that in this case they actually met after, in this case, this after disk C had already actually reached its after it reached its maximum height. So in this case, the graph for object C would simply start at point, in this case that at that point it would decrease, it will actually reach its maximum height, right, and then it will keep, in this case it will end it at a certain point there. So in this case, simply mean that in this case it will simply be in this case the time when it reached, in this case, the maximum height, which was in this case 1.53. So in this case, this will simply be in this case when, in this case, it passed, in this case that it hits that object there, which is actually 1.71 there if we round that off, right? So in this case, for object, in this case B, so this will be in this case for disk C, right? So in this case, so for object, in this case for object B, right, so in this case it started with a positive velocity, right? But in this case, remember that in this case the object B would not actually start at that point. Why? In this case, because it was projected, in this case 0.5 seconds later. So in this case, it actually start, in this case, at that point there. So in this case, as it was going up, its speed was decreasing until, in this case, it hits that that object C there. So let me just draw that nicely, right? In this case, what I'm simply going to have would be something like that. Now remember that in this case, object B, in this case, it did not reach. So when they hit each other, that object C there, in this case, when they passed each other, in this case that object B, in this case didn't, in this case it wasn't, in this case it didn't actually reach, in this case, its maximum height yet. So in this case, it would not actually, in this case, it would not actually cut that, in this case, that x-axis. Remember that this is time. All right, so in this case that is time in seconds. So in this case this is the type of graph that you're actually going to have. So in this case, what you're simply going to do there would be, so in this case, this would be, in this case, for ball B. So in this case, it's going to start there. Again, you can note the same thing, that in this case that the velocities of these objects would not actually be the same if you look at it. So in this case, you notice that this one and those velocities are actually not the same. So in this case, what I'm simply going to do, ladies and gentlemen, would be to end this lesson here. Right now, if this video helped you at some extent, be sure to like it and also leave a comment right now, or in this case, if you haven't subscribed, be sure to become part of the family. Now, if you have any topic that you are struggling with, or any topic that you would like me to cover, you can actually suggest that in the comment section. I'm open to all suggestions, ladies and gentlemen. So if you have anything that you would like me, any topic that you'd like me to cover, whether being in maths or physics, just throw the topic in the comment section. Or if you want me to constantly go through past papers, you can just say so, and I'll do that. Right? But otherwise, as the story always ends, ladies and gentlemen, this is Sir Mike signing out. Sharp, sharp.